Let us see what is synthesis in VLSI. In VLSI, synthesis refers to the process of converting a high-level behavioral or functional description of a digital circuit, which is written in hardware description language like Verilog or VHDL, into a gate-level language, which describes the circuit in terms of logic gates and their interconnection. So, in simple words, it is a process of transforming RTL into gate-level netlist. Here, RTL stands for register transfer level. Synthesis is described as translation plus logic optimization plus mapping. So, that's what I have mentioned it here. And it involves these steps. Initially, the HDL, hardware description language, gets converted into generic Boolean logic. After that, some sort of optimization will happen, and again mapping will be happening. And once mapping is done, again optimization will happen, and again we get final gate-level netlist. So, this is the diagrammatical representation. Initially, our HDL code will get converted into generic Boolean logic during the stage of translation, and again this generic Boolean logic will get converted into target dependent gate-level netlist. Means here target dependent means suppose if you want to convert this one into 45 nanometer, then you have to use 45 nanometer dot. So, these things will happen during the process of optimization and mapping. So, HDL, generic Boolean logic, after that optimization, mapping according to the technology node, and after mapping also some sort of optimization will happen, then we get final gate-level netlist. Here HDL stands for hardware description language, means our Verilog code. Next, generic Boolean logic means generic gate-level netlist, which is independent of technology. So here generic gates gets inserted, which is not technology dependent. Then optimization will happen. So optimization is done to meet the constraint. So generally you can take optimization as something called as a Boolean minimization, so that our best PPA can be achieved. That is, power, performance and area are our main goals in synthesis. Then mapping. Mapping will be done based on dot lib that we are providing based on technology. So here this dot lib will be technology dependent. So here technology dependent gate will get inserted. So then we get the final netlist, which is finally optimized gate level netlist, that is dependent on the technology node. So depending upon the technology, we get final gate level netlist. Now let us see what are goals of synthesis. First one is functionality. Ensure correct translation of RTL into gate level netlist. So initially we are providing RTL, and at the output we are getting gate level netlist. So functionality should be matched. So this can be checked by using a tool called as conformer LEG. Next, timing closure. Meet timing constraints. So here it depends upon clock period, setup, hold times and so on. So generally there are some of the constraints. We will be seeing them in more detail in the upcoming videos. Next, we need to achieve area optimization. So this will minimize the design area to reduce cost and size. Power optimization means reduce dynamic and leakage power consumption. Design rule compliance. So we need to adhere to design rules for manufacturability. Then testability. So include DFT like scan chain logic. So DFT means the normal clocks will get converted into scan clocks. Next, optimize fan out and drive chain. So here fan out means by using one single gate, how many different gates that we are able to drive by using one output of that gate. And here drive chain means it will be like X1, X2, X4, X8 and so on. So drive chain can be increased by increasing the width, so that more amount of current will flow and it leads to reduction and the delay. But the problem here is if you are increasing drive chain, area will increase. Next, coming to technology mapping. Map logic to standard cells from the technology library. So depending upon the technology library that you are providing, mapping will happen during mapping stage. Power domain handling. So insertion of level shifters and isolation cells for multi-voltage design. Suppose if you are working on multi-voltage design, then these cells will get inserted called as level shifter cells, isolation cells, and two more are there which are always on cells and retention clocks. So finally, logic equivalent between RTL and netlist should be maintained. As I told you, this should be checked by using a tool called as conformer LEG. These are the goals of synthesis.